Hi Year 12 Maths General students. This lesson is from Unit 4 of the Queensland Maths syllabus, and we're looking at reducing balance loans today, which essentially are just loans with regular repayments. The lesson objectives are we're going to use recursion models to calculate the remaining balance of a reducing balance loan after n compounding periods. Calculate the total amount of interest paid between the initial loan balance, which was your A0, to the required number of compounding periods, which is AN. Lastly, we're just going to look at a variety of different problems involving calculating interest saved by making extra repayments on a reducing balance loan. So far, we've only considered the balance of the total loan amount borrowed. So we've only looked at the principal and interest accrued using recursion, given that someone pays the entire loan off in one repayment at the end of the loan. Now, this isn't really realistic. Most loans don't work that way, and banks make sure that paying off the loan is manageable. So it's more likely that the bank will incorporate a constant set of repayment amounts, which means that you'll pay the loan off over the period of the loan agreement. Home loans and personal loans are examples of reducing balance loans. The home loans that your parents or family friends may have, and personal loans that people may get from financial institutions are all examples of reducing balance loans. With reducing balance loans, we use a combination of arithmetic and geometric sequences. However, we need to use the financial terms with capital A representing balances, R represents our interest applied to the loan, AN, in this case with reducing balance loans, represents the balance after a certain number of compounding periods, and capital R represents the repayments we're making per compounding period. Now, lucky for you, this is also on your formula sheet, so you simply need to look that up when you're trying these types of questions. As a side note, banks are always looking out for their best interest. So when interest is calculated on these reducing balance loans, it's always calculated from the highest balance amount for that compounding period. So the formula always considers applying interest to the highest balance owing in the account for that compounding period. So for example, for a month, and then the repayment gets subtracted from it. This affects scenarios where you may be making extra repayments. All right, let's look at some examples. We're going to start off with two simple familiar type examples. The first question tells us we have our friend Terry. He's borrowed a total amount of $5,000 from a bank at 8% per annum adjusted yearly. So that just, remember, means compounding yearly. So it gets hit with interest once a year. He's required to make repayments of $500 each year. Determine how much he still owes on the loan after 4 years using recursion. If you feel confident working ahead with this question or any questions during this video, press pause, have a go at the question, and then check in afterwards. To start the question off, I would hope that everyone is in the habit of annotating important information within their question. So we have a look at this first part. He borrows a total of $5,000. So in this case here, that becomes our A0. Our interest is 8%. It compounds yearly, so that means our K or compounding period is 1. And he's required to make repayments of $500 every year. So our capital R is 500. Lastly, we need to consider that we need to find out how much he owes on the loan after 4 years. So that means when we're applying recursion, we're after the balance after 4 years, which is our fourth recursion. Again, another good habit is always to write down your facts once you've processed the question. The information I'm missing is the little r or common ratio. So R is going to be 1 plus our interest over 100 times the compounding period, which in this case is 1. It gets hit with interest once a year. And if I chuck that into my calculator, I get 1.08. So now I have enough information to develop my recursion formula. So my recursion formula for this reducing loan is an plus 1 equals 1.08 times a to the n minus 500. Now that I have this, I can calculate the fourth recursion. So let's work through and find out how much he still owes on the loan once I get to that fourth year. So if my A0 is 5,000, to get to my next consecutive balance, I apply my common ratio of 1.08, which is the interest that's being applied to the loan of $5,000, and then I'm minusing the $500 repayment. So I'll quickly show you a good way to put this into your calculators. If we simply take the initial amount, enter it in and press equals, that stores the initial amount into your calculators. And then we can set up a very simple recursion process by using the answer button, telling it to multiply it by our rate, and minusing the repayment. So after 1 year, I will have a balance of 4,900. Because your calculator will then use this new answer, simply by pressing equals, it will refer to the answer you have, apply the rate of 1.08 minus the $500 repayment. So for our A2, so after 2 years, that will be the balance. After 3 years, we have $4,675.36. After 4 years, Teddy will have a balance of $4,549.39, rounding that to the nearest cent. Finally, just make sure you document your working for this. So we can see that we've shown each of the recursions made and our conclusion where Teddy will still owe $4,549.39 after 4 years. Question 2, another simple formula question. We have Alyssa who takes out a loan totaling $4,800 from a bank at 15% per annum, and this time it's adjusted monthly. So every month she gets charged with interest. We need to firstly develop a recurrence relation model that can be used to determine the balance of the loan at the end of each month if she's required to make monthly repayments of $250. Part B wants us to use the recursion relation to find the balance after 5 months. So we're looking at 5 recursions there. And then lastly, determine how much you would still owe after 1.5 years and round it to the nearest cent. Going through and annotating the important information there, our loan value is 4,800, so that's our A0. Our interest is 15%. Adjusted monthly means our K value is 12. Reading into part A, monthly repayments for $250, so that's important as our capital R repayment value. For part B, we want the balance after 5 recursions, so we're after our A5. And in terms of part C, we want the balance after 1.5 years. So doing a very quick calculation, 1.5 years times 12 months, 18. Which means that we're after the A18 or 18 recursions. After writing down all of my facts, which is a great habit, the first thing I need to work out is my interest rate, so the rate that gets applied to the balance. So remember that's 1 plus I over 100 by K. So in this case, I've got 15% over 100 by 12 compounding periods. And if I chuck that in my calculator, I get an little r value of 1.0125. Setting up my recursion model now of that reducing loan scenario, I simply just substitute in all of those values into my given formula, which remember is on your formula sheet. Okay, so to answer part A, our recursion relation model is a to the n plus 1 equals 1.0125 times a to the n minus 250. For part B, we need to determine the balance after 5 months. So we're after our fifth term in the sequence. Again, we'll set this up in our calculator so we can easily apply those recursions. So as I showed you earlier, enter in your initial borrowed amount, which is 4,800. Then to make the calculator do the work for you, simply press the answer times your rate, which is 1.0125, and subtract that repayment of $250. So all you have to do is press equals for each recursion. So our first recursion after 1 year will give a balance of $4,610. When I'm documenting my answer, you'll notice that I've skipped a couple. As long as you're demonstrating you know how to calculate each one, we simply just expect you to be able to use your calculator because we can clearly see how you know how to calculate the next consecutive balance. So let's get stuck into finding our fifth recursion. So at the moment, that's our first, second, third, fourth, and fifth recursion, showing us that Alyssa, after 5 months, owes $3,825.95. Part C, we're simply trying to find the 18th recursion. So this is where using that calculator entry is really, really handy because we're up to our fifth, so we just need to press this until we get to our 18th recursion. So 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th recursion. So this means after 1.5 years, Alyssa will owe only $991.22 on her loan. She's getting super close to being able to pay it off now. Let's make sure we document our answer. And we're done. One of the other skills we need with reducing balance loans is being able to calculate the amount of interest that's been paid after a certain amount of compound periods. To calculate the total interest paid after a certain amount of compounding periods, we take the balance at that point in the loan, or the AN, and we subtract away the initial value of the loan, the A0, and then we simply add on the amount that's been repaid over that period of time, which is your N by your repayment value. Let's apply this to Alyssa's scenario from question 2. If we wanted to know how much interest she'd paid after 1.5 years of paying her loan off, we could easily find that using the formula above. So after 18 months, she had a balance of $991.22. Her initial value of the loan that she took out was $4,800 and her repayments were $250. So because N is 18, we simply apply everything into that formula. So $991.22 minus our initial loan amount, add on the fact there were 18 lots of $250 repayments. Plug this into our calculators. This means that she's paid $691.22 interest during the 18 months she's been paying that loan off. Of course, making sure we document that. Let's try some examples now. The first question we have there, question 3, is a simple familiar, and question 4 gets us to consider a scenario where extra repayments are made. And you'll be able to see that essentially when you make extra repayments, you don't pay as much interest and you end up saving a whole heap of money by paying off the loan earlier. Again, if you'd like to try the questions without me going through it, press pause, have a go at them, and then check in afterwards. Okay, we have Henry who's borrowed $20,000 from a bank at 8.4% compound interest adjusted quarterly. Standard repayments are set at $1,500 per quarter. So firstly, go ahead and annotate all the important information. So our loan amount A0 is $20,000. Our interest is 8.4%. Adjusted quarterly means our K value is 4. Repayments are set at $1,500 per quarter. So our capital R is 1,500. After documenting that information, let's work out our rate that's being applied in terms of the interest. So I've got our 1 plus 8.4 over 100 by 4, giving us a little r value or common ratio or rate of 1.021. Okay, so now that I've processed all the information, let's look at what the question's asking us to do. We want to develop a recurrence relation model that can be used for Henry's loan. We need to determine the balance after the first 2 years of the loan, rounding to the nearest cent, and then finally calculate how much interest Henry will have paid after the first 2 years of that loan. So for part A, our recurrence relation model is going to be a to the n plus 1 equals 1.021, which is our rate, by a to the n minus our repayments of 1,500. For part B, we need to firstly work out the number of quarters or compounding periods that have gone by in that first 2 years. Remember, the number of compounding periods is just the time by the number of times whatever financial scenario you're talking about gets hit with interest. So we've got 2 years and it gets hit with interest 4 times a year. So the number of compounding periods that's gone by is 8, which means we're after our 8th recursion. Again, set up your model within your calculator so you can easily calculate those recursions. To get our first balance after 1 recursion, we take our rate by that loan amount minus our repayment. Set that up in our calculators, remembering that we'll enter our initial loan amount. So the calculator will remember it, and then set up our recursion itself. So whatever our previous balance was, we're telling the calculator to multiply it by the 1.021 rate and always minus a repayment of $1,500. So after the first quarter, there'll be a balance of $18,920. We're after the 8th recursion, so I'll press equals another 7 times. So 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. So after 2 years, our friend Henry will have a balance of $10,697.58. From here, make sure you document your answer. You'll notice that I've only got 1 recursion there. 1 or 2 is fine, as long as we can see that you're demonstrating you know how to use the process of recursion. For part C, we're interested in how much interest Henry has paid over those 2 years of paying that loan off. So we simply substitute everything that we know into the total interest formula, subbing in the value of the loan after 2 years, which was my 8th recursion of $10,697.58, minus my initial loan amount, which was the $20,000. And I'm adding on the fact that there were 8 repayments of $1,500. Chuck that into my calculator. And this means that he's paid total interest to the bank of $2,697 and rounding that up to 58 cents. The last question. As you can see, it's a complex familiar question. So here we have John, good old Jono. He buys a house and takes out a loan for $350,000 from a bank at 3.82% per annum, compounding monthly. And we have minimum repayments of $3,052.65 per month over 30 years. So this looks like a typical house loan scenario. And you notice it says minimum repayments because most banks give you the option of making extra repayments. The next part says, after budgeting carefully, John sees that he can easily afford repayments of $4,000 a month. We need to construct a recursion relation model and calculate how much interest our friend Jono will save over the first 6 months of a loan by making these extra repayments. So our loan amount, or A0, is $350,000. Our I is 3.82. It's compounding monthly, so that means our K value is 12. Minimum repayments, it's like a 2-part scenario of this question. So repayment 1 is $3,052.65. Repayment 2, when we consider how much you'll save, is $4,000. And according to the question, we just need to look at the first 6 months. So we're after our 6th recursion. Write down your facts. The first part of extra information that we need is the rate itself. So we find that by doing 1 plus 3.82 over 100 by K, which in this case is monthly, so it's 12. That gives us a little r value of 1.003183. Okay, to set up these scenarios, we need to compare the different repayment scenarios. The first thing we need to do is set up our recursion models for each scenario, and you can see what I've done there is just simply substitute the information I have using the formula that I'm recalling, which, remember, this one in particular is on your formula sheet. I then need to work out after 6 recursions what the balance on each scenario is. Remember to enter that into your calculator by putting in your initial loan amount, pressing equals so your calculator stores that. Then to make it consistently do your recursions, take that amount, multiply it by your rate, subtract your repayments, so after the first month that will be your balance. We'd just like to see a demonstration that you're applying your recursion formula. So you don't need to put all 6 recursions in, just put 1 or 2 in, and then your final answer. So after 1 month, the loan balance would be $348,061.40. Just as a side note, you would have noticed that I rounded the rate. So for the purposes of this question, my answers will not be 100% accurate because banks will use the whole interest rate. So when this was calculated previously, it was had threes recurring after that final number. So this will affect the accuracy of your answer. But for the purposes of 12 Maths General, rounding that R value is perfectly okay. So if we do a further 5 recursions, so that was after our first month, second month, third, fourth, fifth, sixth month, the balance on the loan will be $338,275.45. Okay, let's consider the second part of the scenario where he's making extra repayments. So here he's making repayments of $4,000 instead of the minimum. So you'll expect that the balance will reduce quicker and he'll save on interest. When we set this up, applying everything into the recursion formula, you'll notice the only thing that's different to scenario 1 is this change in repayment value. Our value after the first recursion or first month is $347,114.05. Second month, third, fourth, fifth, sixth month, the balance on scenario 2's loan will be $332,545.92. Okay, so even without looking at the interest that's been paid, you can see that in scenario 2, he owes a lot less money after 6 months than in scenario 1. Okay, let's go and work out how much interest has been saved from this now. Okay, so for the amount of interest paid, we're using this formula up here. So we take the balance of the loan minus the loan amount that was borrowed and add on the number of times that repayment was made. Scenario 1, we pop in the balance of the loan minus its initial value and add on the fact that there were 6 lots of our repayment made. Pop that into our calculators. And that gives us a total of interest of $6,591.35 paid. And if we go and work it out for our second scenario, we can see in that scenario a total of $6,545.92 worth of interest has been paid over that 6 months. So lastly, we need to look at the difference of interest. So how much has he saved? Is that I've labeled them as I1 and I2. I simply will find the difference between those two values, and that will give me the amount of interest that he saved over that 6-month period. Plug these values into our calculator, and that gives us a total interest saved of $45.43. So he makes a saving of $45.43 paid in interest paid back to the bank over that 6 months. Now this doesn't seem like a lot of money, but over a 30-year period of a house loan, those repayments can make a significant difference in the amount of interest you pay the bank. Because looking at the interest paid over the period of 30 years would mean that you're examining 360 recursions. That's not very practical for questions where you're required to demonstrate the calculations by hand. So in the next video, we're going to look at how we can use technology to investigate those longer period reducing balance loans. So just finishing off this question, it looks like Jono would be very wise in making these extra repayments towards his loan, because over that 30-year period, like I said, he would end up saving a lot of money. Okay, the takeaway points from this is just making sure that you're familiar with using the reducing balance loan recursion formula. Although not very practical for large periods of time, we are required to be able to use it. The other takeaway point from this is you need to be able to work out the total interest you've paid after a particular number of recursions. So using that total interest formula, as you can see, is pretty straightforward. And above all, if you can take any message home about borrowing money from a bank or financial institution, especially down the track when you're taking out your own loans for things like cars or houses, if you make extra repayments on any loan that you take out, you'll save on a lot of interest that you're charged by these financial institutions. So if you can afford it, always make extra repayments on loans. Thanks, Year 12s.